Okay, so on this example, we're supposed to take the limit as a goes to 0 of this kind of complex function. So if we plug in 0, it's not going to work. Let's put a 0 there and a 0 there for a. You're going to get 1 over 81 minus 1 over 81 over 0, which is 0 over 0, which is unclear. And so we don't know what that means. Didn't work, so we got to do something else. What are we going to do? Well, you see the answers right here. How did they get to that answer? Well, we have to simplify the complex fraction is what we have to do. So somehow we have to make that happen. So basically, let me write a note. When you have fractions over fractions, it's called a complex fraction. So there's fractions over fractions. Well, at least it's a fraction in the top of a fraction. Although, yeah, maybe I should say fractions within fractions. When fractions in the top or the bottom. Let's put it that way. Whenever you have a fractions in the top, if you have fractions in the top of a fraction, that's called a complex fraction. And whenever you have a complex fraction, whenever you have that, you need to simplify it. Now, how do you simplify it? Well, you multiply all the terms, top and bottom, by everything in denominators. I don't know if that confusing sentence made sense. Let me show you. So you look, okay, here's a denominator. Here's a denominator. That's all. You might say, well, you might say the A is a denominator. Well, yeah, but it's not a denominator within a fraction, right? It's just the overall denominator. So just the by everything in, I should say the small denominators. So let me show you. So it's the limit as A goes to 0 of 1 over 9 plus, my 9s look like A's, don't they? 9 plus A squared, there we go, minus 1 over 81 over A. Okay, now I'm going to multiply by, no, oh boy, my 9's looking like A's again. 9 plus A squared times 81. Same thing here, 9 plus A squared times 81. And down here, 9 plus A squared times 81. See how I multiplied all the terms, top and bottom, by everything in the small denominators. So 9 plus A squared and 81, 9 plus A squared 81, 9 plus A squared 81, 9 plus A squared 81. So I'm doing the same thing to all the terms top and bottom. So I won't change the value of the fraction. I'll just change the way it looks. It's like a fancy plastic surgery, right? You're removing the wrinkles. It's the same person when you're done. So all I'm doing here is I'm multiplying all the terms top and bottom by all the little denominators. Now, why? Why that? Well, because that'll cancel out. Boom, boom here. Boom, boom there. So that'll leave us with the limit as A goes to 0 of, what's left here? Just the 81 minus, what's left here? The 9 plus A squared. What's left on the bottom? Well, everything. Nothing canceled on the bottom, which is fine. Okay, so that makes sense. What happened? So right here, the 9 plus A squareds canceled and only 81 was left. Here, the 81's canceled and only the 9 plus A squared was left. See how it's a normal fraction now? It doesn't have fractions in the top or bottom of the fraction. It doesn't have fractions inside of fractions. It's not a complex fraction anymore. It's easier now. Okay. Let's also, next step, we're still simplifying here. Um, let's multiply out this. This means 9 plus A times 9 plus A. And so I'm going to go first to both. It's 81 plus 9a, and then the second to both plus 9a plus a squared. It's 81 plus 18a plus a squared. These two 9a's made 18a. Okay. Now, where are we at? Let's keep this going. So we are taking the limit as a goes to 0 of 81 minus, and then we have this oops, stuff right here. 81 plus 18a plus a squared. And on the bottom, a 9 plus a squared times 81. Okay. So I just multiply. By the way, the common temptation is to square and square and just make it 81 and a squared, but that's not right. It does have an 81 and a squared, but it also has an 18a. Remember, when you have a square on parentheses, you got to write two of them, FOIL the whole thing out. Okay, now this minus sign in front of the parentheses is going to distribute. So we'll get the limit as a goes to 0 of 81 minus 81 minus 18a minus a squared a 9 plus a squared times 81. These will cancel. We're getting so close. And, well, take another step. I'm trying to do too many steps here. Limit a goes to 0 of minus 18a minus a squared a times 9 plus a squared. Well, hope you can tell my 9's from my a's. 9 plus a squared times 81. All right, now let's take the limit as a goes to 0 of, now on the top, it's factor time again. See how both these have a in common? In fact, let's take out a minus a, and that'll leave 18 plus a. Yeah. And on the bottom, we still have a 9 plus a squared times 81. It's times. Okay. Right. See how I did that? Because minus a times 18, go back to minus 18a, minus a times plus a be minus a squared. Now, these a's can cancel because they're multiplied. You can cancel multiplied items. They're not added or subtracted items. So then this leaves me to the limit as a goes to 0 of, we're really close now, 18 plus a over 9 plus a squared times 81. Now we can plug in, a is going to 0, right? Oops, I scribbled that. A is going to 0. You can plug in your 0 and plug in your 0. Now it'll work. Why? Why does it work now? Because we got rid of these guys. They were what was making the 0 over 0 happen. So all that was to get rid of them. So it's now it's 18 plus 0 over 9 plus 0 squared times 81. So that's 18 over 81 times 81, right? Because 9 squared is 81. We can reduce that fraction a little bit, I think. Um, you just use your calculator. 81 times 81 is some gigantic. What I'm going to do is I'm going to divide by 9 right here. Divide by 9, divide by 9. That leaves 2, 2. So that's 2. No, not 2. Sorry. I'm getting tired of this problem. There's 9. So leaves 2 over 81 times 9, which is 2 over 729. So that's the final answer. Oh, and I forgot the minus along the way. Where did the minus go? Where did the minus? I can't believe I lost. Oh, right here, this minus sign. Sorry, guys. I lost that minus. He should have been there all along. I was just testing you, really. I'm just kidding. All right. There we go. Minus 2 over 729. Don't forget about that minus. It's there. Easy to forget about that. That was a pain, wasn't it? Let me recap. So what do you do when you've got fractions over fractions? We call that complex fractions. You multiply all the terms top and bottom by everything in the tiny denominators. So that'd be 9 plus a squared and 81, 9 plus a squared and 81, top, all the terms top and bottom, and then you cancel. Leaves 81. And then we canceled the 81s, leaves that. And then the bottom just stays as it is. Then I had to multiply that out and got that, gathered like terms, and then distributed the minus sign all the way through, then canceled. Then I factored again, factored out the A or the minus A right there, and then the A is canceled. That's you're going until you have a cancellation. That's what you basically need. Get to here, don't forget that minus, it's in front, and plug in your zero then, and then just simplify your numbers. Now, here's some other forms. Here's an easier form. You might have got this one, or you might have got this one. These are easier forms of the same thing. Let me show you how to do this one. So this one, same thing. So you look at the small denominators and you say, all right, I'm going to multiply by those. So that's going to be 9x plus 2, 9x plus 2. And then on the bottom, no choice, same thing, 9x plus 2. So you multiply all the terms, top and bottom, by everything under the little bars. Okay? And then you cancel. This is what will clean it up. X plus 2 cancels x plus 2. So it's the limit. X goes to 7. We're left with this. This will bring down just the 9 here, minus, and here the 9 will cancel the 9, x plus 2. And on the bottom, we have the x minus 7, the 9, and the x plus 2. Do you see that? So I multiplied, again, whenever you got fractions within the top or bottom of a fraction, you'd look at the little denominators, x plus 2 and 9. You multiply by both those things, 9 and x plus 2, all the terms top and bottom, and then cancel. That gets rid of the little denominators. So you have a 9 in that. Now you might say, okay, great, that's great. Just cancel these out right now. No, 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 no. Remember, that's a subtracted item. You cannot cancel added and subtracted items. Only multiplied items. Remember that. Really important. That's a big mistake that a lot of people make. You cannot cancel added, subtracted items. Only multiplied items, terms they're called. Right? Can't do that. You can't go like that. No, no. It's not true. You can prove it with numbers. It's just not so. Um, so what do you do then? You distribute. So then you say, okay, so this is the limit. So x goes to 7 of 9 minus 7x minus 14. Right? That minus, wait, no, that's not a 7 there. What am I doing? I'm getting totally lost. You just distribute that minus sign. Minus x minus, I don't know why I thought there was a 7 all of a sudden. Just that minus sign right there just distributes. On the bottom, nothing's changed. Okay, now can you simplify that top? A little bit more, you can. Okay, 9 take away 2 is 7. So this is 7 minus x over x minus 7, 9, x plus 2. Okay, we're almost there. Remember, what we need something to cancel. Here's the first thing we're going to do. I'm going to flip these around. I'm going to make this minus x plus 7 instead of 7 minus y, because I want it to match with this guy. So you always want x's in the front, right? So 9 minus 2 is 7. I put the plus 7 in the back, and I put the minus x in the front. Now, they don't exactly match, right? This is negative, this is positive, positive. What are you going to do? You're going to factor on the top. You're going to say, okay, it's a lot of algebra lessons here. This is what you're meant to learn. It's all these algebra. This is what makes or breaks calculus students is getting down all these factoring kind of fraction and factoring and negative rules. When the front is a negative, you got to take out a -1. That changes it. See that? See how if I was to take that -1, boom, minus x, and minus times minus plus 7, and now they cancel. And there it is. That's like the green light. You're waiting at the stoplight. You're waiting. It finally turns green. That cancellation is the green light to what? To plug in the 7. Now we can do it. Come back here and write what we've got. We've got minus 1 over 9, x plus 2. Now we can plug in. Let x go to 7. Plug in that 7. Get minus 1 over 9 times 7 plus 2 minus 1 over 81. It's 9 times 9, isn't it? There it is, minus 181st, as we saw. Let's try one more. You might have had this version. This one's even easier. So I don't mean to act like these are easy, but they're getting easier now. So you look and you go, oh, that's fractions over fractions. Fractions in the top of a fraction. How do you handle those? You multiply. You take a look at the items under the little bars and you multiply by both of those, 5b, 5b, and the bottom, 5b, right? All the terms, top and bottom, you've got to multiply. Now you might say, Mr. Why didn't you put a 5b right there and right there? You could. You could distribute. It would do the same thing, but it's going to be easier just to leave it. It's the same either way, but I know it's going to be easier this way. Okay. You'll see why. B's cancel B's, fives cancel fives. That's why we do it. We want to cancel out those little denominators. But we got to do the same thing top and bottom, right? To keep the fractions value the same. What are we left with? 5 minus B, right? This is just 5 now. This is just B now. On the bottom, B minus 5 times 5B. Do you see why I'm doing that? Because you see how these guys are almost the same, but not quite. So what are we going to do? We're going to reorder this and write it minus B plus 5. So remember, you can reorder things anytime you want as long as you keep their signs with them. The minus sign is on the B, the minus sign is on the B. There's nothing in front of the 5, there's a plus in front of the 5. That's the same thing. So you can reorder, but you got to keep their signs the same. Okay. So then we have the limit as B goes to 5. We're waiting for the big cancellation. That's what we want. Minus B plus 5 over B minus 5 times 5B. Now, oops, sorry, I'm making the thing move around. Limit B goes to 5 of, remember what you do with this? You factor out a negative 1. That leaves B minus 5. Now it matches the 1 on the bottom. See how that's correct? Minus 1 times B goes back to minus B, and minus 1 times minus 5 goes back to plus 5. See that? And now, boom, they cancel. That's the green light, right? Now we're going to be able to plug in the 5 for the B because we canceled. Left with minus 1 over 5B. Now let B go to 5 right there. Minus 1 over 5 times 5 minus 1 over 25. And there we go. That's the right answer. So that's how we do those.